Yeah, hi. So this will be our last video for the week, and we will focus on some additional examples regarding yung ating ISR evaluation, yung ating ISR CPU percentage, and ISR or interrupt overhead or ISR overhead. So, as a recap, ang pinaka-important dito na tandaan is yung ang ISR CPU percentage is yung number of instructions times frequency of instructions all over yung ating clock frequency or CPU frequency times 100%. Tapos, ayan, let's get right into it. First example is consider a timer interrupt that is configured to occur every 10 milliseconds with an ISR that finish after 71 instructions, including yung save and context save and restore. Then an external interrupt with an ISR that finishes after 508 instruction cycles is connected to an input that changes state 5 times per second on average. So, assuming an instruction frequency of 8 MHz, compute the following. So, number one, ISR execution time for each interrupt and yung CPU percentage for both interrupts. So yeah, let's just tanggalin na yung extra words dun sa ating question. And ito lang given talaga sa atin. May timer interrupt na once every 10 milliseconds and then 71 instructions per ISR. Sa external interrupt naman natin, 5 times a second naman siya and 508 instructions per ISR. And yung ating instruction frequency ay 8 MHz. So, ayan, execution time for each interrupt. So that's just yung number of instructions over ating frequency of instructions. So for the timer, 71 over 8 meg. For the external interrupt, it's 508 over 8 meg. So 8.875 microseconds from the timer and 63.5 microseconds for the external interrupt. So yeah, yung CPU percentage naman, so yun, kung meron na tayo ng execution time per interrupt, multiply lang natin siya sa frequency ng interrupt. And ayun, so 8.875 times 1 over 10 milli, so 100. And then we have 63.5 times 5 naman. So for the timer, we actually get 0.08875%. And then for the external interrupt, we have 0.03175. So I guess ito yung isang example na, okay, mas konti yung instructions ng timer natin kesa doon sa timer ISR natin compared dun sa external interrupt ISR na 508. But it turns out na in terms of CPU percentage, mas gamit natin si timer interrupt in this case. So, mas mataas siya by 0.05% dahil lang mas madalas siya mangyari kasi once every 10 milliseconds siya. So, what does that tell us? If gusto mong i-improve yung CPU percentage, baka kahit 71 instructions to, baka pwede mo pa siyang babaan. So, something na magkakaroon ng or maging relevant yung pagbawas ng instructions is this one. So, next example, which we want to incorporate yung paggamit ng shadow register set. So, meron tayong comparator interrupt that takes 96 instruction cycles and enables a timer interrupt that triggers twice before being disabled again. So, every time na ma-trigger si comparator, mag-trigger twice yung timer. Si timer naman meron siyang 69 instruction cycles, yung kanya ISR. Assuming that there's only one shadow register set, which reduces either ISRs by 10 instructions, identify the following. So that means na pag ginamit natin yung shadow register set kay timer interrupt, magiging 59 na lang siya. Pag ginamit natin siya sa comparator interrupt, that means 86 instructions na lang siya. So question number one, or task number one, find the minimum combined ISR CPU percentage. So combined ISR CPU percentage is just yung CPU percentage ng comparator plus yung CPU percentage ng timer. And ayan, so combined ISR CPU percentage that could be achieved in terms of the frequency of the comparator interrupt if the instruction frequency is 8 megahertz. So ano yung minimum combined ISR CPU percentage? Then the next question, if the timer interrupt could be reduced to 46 instructions, which interrupt should we use the SRS for a lower CPU percentage? So parang medyo same question, but in the second case, binabaan natin yung number of instructions ng timer. So yeah, let's just i-strip down natin to what is really given. So, yung frequency ng comparator interrupt is not given, pero pwede natin siyang ilagay as a variable. And yung number of instructions for the comparator interrupt service routine is 96. For the timer interrupt naman, yung frequency niya, since magte-trigger twice yung timer for every time mag-trigger once yung comparator, that's 2 times x. Number of instructions is 69. And then, instruction frequency natin is 8 megahertz. And then yung savings natin from using the shadow register set is 10 cycles. So, I guess kung gusto natin makuha yung combined ISR CPU percentage, we have to compute yung individual na ISR CPU percentages. So, let's do just that. But before we proceed, let's first assume na si comparator yung gagamit ng shadow register set. So, pag nag-compute tayo, yung ISR percentage ni comparator is 86 times x over 8. And then yung sa timer naman is 69 times 2x over 8 times 10 to the 6, or 8, 9. So, this one is 1.075 times 10 to the negative 3. And then 1.725 times 10 to the negative 3 per times yung frequency ng ating comparator percentage points. So if we add those up together, we get 2.8 times 10 to the negative 3 if we use the shadow register set on the comparator. Then we compare this to the case na ginamit natin yung shadow register case sa timer na interrupt. So itong 86 dito, magiging 96. And yung 69 originally, magiging 59. So using the same computations, the same formulas, nakikita ko natin dito is that 2.675 times 10 to the negative 3 x percentage points yung ISR CPU percentage natin. So, ayan, compare this dun sa 2.8 nung ginamit natin sa comparator, we can conclude na we have to use yung SRS on the timer ISR to achieve yung minimum combined ISR CPU percentage na 2.675 times 10 to the negative 3 times x, or yung frequency ng ating comparator interrupt. So, the next question is, if the timer interrupt can be reduced to 46 instructions, alin naman, or magbabago ba yung sagot natin? Timer pa rin ba yung gagamit ng shadow register set? So, ayun, let's just compute. Similarly sa kanina, na, ayun, kahit nga yung clock frequency natin is gawin nating variable, makikita natin, makuha natin dito is 178x over FCY, yung ISR percentage pag ginamit natin sa comparator. So 86 siya, 46 si timer. Pag 96 si comparator, 36 si timer, makukuha natin is 168. So, regardless of the clock frequency ng ating instructions, makikita natin dito na mas mababa yung CPU percentage pag ginamit pa rin natin siya sa shadow register set. Or ginamit pa rin natin sa timer interrupt yung shadow register set. So, as a food for thought or something na pwede niyong pag-isipan, kasi baka lumitaw sa quiz, is there a case where the shadow register set should be used with the comparator instead of the timer interrupt? So, ano dapat yung mangyari para maging mas mababa yung CPU percentage pag kay comparator binigay yung ating pag kay comparator binigay yung ating shadow register set. So, will that mean kailangan ba dagdagan or pag ba mas marami pa yung instructions na kailangan for the timer, mas maganda na ba siya sa comparator? Pag ba tumaas yung frequency relative doon sa other one? So, yeah, something that you should think about. So, yeah, so for the third example, we have a sort of word problem. So two interrupts occur 300 times and 500 times a second, respectively. If both their ISRs have the same execution time and account for 2% of the CPU time when combined, answer the following. So first one is ano yung execution time ng interrupts, and then ano yung combined ISR CPU percentage if the instruction frequency is doubled. So para lang siyang word problem talaga. Meron tayong interrupt na 300 times, meron tayong interrupt na 500 times. So, hindi ko alam bakit may K dyan, pero ayan. So, yung execution time natin, di ba, sabi pareho. So, yung ISR percentage is T times 300 times 100 for the 300 times, and then times 500 sa 500 times. So, ang combined nila, sabi is 2% dapat. So, T times 300 plus T times 500 dapat 2%. So, yeah. So, isolating T, you should get that yung ating T is 25 microseconds. So, execution time for both interrupts is 25 microseconds. And just to double check, pag pinlog in natin yung 25 microseconds dun sa times 300 times 100%, tsaka dun sa times 500, we get yung ISR percentage nung 300 times as 0.75 and yung ISR percentage nung 500 times as 1.25. And pag pinag-add nga natin sila, it results to 2%. So yan, yun yung ating first question. T is equal, or execution time natin for both interrupts was 25 microseconds. So, the next question is, ano yung combined ISR CPU percentage if the instruction frequency is doubled? So, currently, pwede nating sabihin na instructions ISR times, yung total instructions natin is yung time nung isang ISR times yung frequency, di ba? And then, ayun. So, equal dapat to, yung TISR natin, na-calculate na natin kanina as 25. So, 25 microseconds times FCY, equal dapat siya doon sa bagong execution time times twice nung FCY. Kasi yung number of instructions natin dapat pareho lang kahit mag-iba yung instruction frequency. So, ayun. So, yung bago nating ISR is 12.5 microseconds long. So, which makes sense, di ba? Pag nag-double yung instruction frequency, yung time it takes for the interrupt service routine to finish, dapat ma-half natin siya. So, from 25, naging 12.5. Now, using yung 12.5 microseconds na execution time for each ISR, we get yung 12.5 micro times 300 times 100, tsaka 12.5 micro times 500 times 100. So, ang total natin is 0.375 plus 0.625. So, that results to 1%. So, nakita natin na pag dinoble natin yung instruction frequency natin, kaya nating babaan yung ISR CPU percentage natin. Which makes sense kasi di ba pag mas mabilis mag-react or mas mabilis gumawa ng instructions yung ating CPU, mas mabilis din matatapos yung mga interrupts and less yung kanilang percentage na kakainin out of the overall execution or out of the overall program. So yeah, I guess that's it for the examples. I hope you can apply din na pag-usapan natin here with the quizzes, with the exercises, and good luck on your assessment.